to talk after Diego, because we have been moving from the generation of electricity to something that is closer to the demand. So we are seeing a growing demand of water, and we are going to see a booming demand of air conditioning, so of cold. And so the presentation will be about that, and we'll start, as most of the presentation of these days, with a panic session. So the first discussion will be about the data, and data are really putting us in panic. And we will talk a little bit about the how climate change is affecting the growth of the AC demand, and at the same time the AC demand, so the growth of the installed systems is affecting the climate change. So it's a deadlock, it's a vicious circle. And so I will try, I don't think I have to convince you that solar cooling is smart, but we have to talk about that, to understand if this is the right, let's say, path. I'm in line with Manuel Blanco chess teaching that let's talk about that and let's understand if this is the right move we have to make in order to look at the final, at the right horizon. And the horizon is, I try to show that AC is really exponential growing. And finally, I think it will be a proposal to start thinking about a strategy about solar cooling in this region. That would be a critical region for that. So let's panic. It's a picture I made. This one in I think it's the laser is that one. Okay, I made in Shanghai a couple of weeks ago, and you can see that we have an air conditioning unit in each room. So everybody is solving the problem. As soon as they have money, they buy the system, they install it, and that's it. So the grid will do the rest. But it's exactly the same I saw in Cairo, in Amman. This is a picture of Palermo, typical solution. A family has to cool the house. They buy 4 units and they install. I had not time to make one here in Nicosia, but I think it's exactly the same. And this is what's happening. The quantity of energy that is absorbed by the cooling of buildings is growing in this way. It's 3 times since the 1990 up to 2016, and most of this demand is answered by electricity. So now we are more or less at 10% of the overall electricity consumption, and this sector is already a big sector in the, say, energy gasket. So we should consider it, I think, by now in a, let's say, separate way. It's not just part of the building gasket. What's going on with the market? Most of the market was in North America and in Japan. We have seen impressive growth of this market in China. So China is doing the market now, but I would say that the Mediterranean and Middle East, if I consider that Europe demand is mostly in Southern Europe, and Middle East and most of the North African countries, if you add this, you are at the same, let's say, have the same role in the market of the American AC installations. This is it's a couple of years ago, very updated. And the emissions are following the growth of the sector. You see that in 2016, the emissions are mostly related to coal, because the Chinese market that has been growing in a so fast way, and all the energy that is going into the AC units in China is coming, most of the energy is coming from coal. So it's a quite an important sector as a share of the total emission in buildings and then the total emission at all. This is a very weather sensitive consumption. So you see that here we are in the area of heating. Here we are in the area of cooling, and this comfort zone is getting smaller and smaller. All the climate data are saying that we are going to change this shape of this curves. So this is a typical curve in this area of the world. In Germany, they have been starting suffering here because of the heat waves in summer, and the same is in Sweden. So there is a strange new market that is coming on in the northern countries that is for very short periods having the AC to stay at home and fight for this week of heat waves. But the general changing of the shape of this curve is showing that we are going up and we are moving to higher temperatures. So the problem is going to be quite bigger in future. That means in collecting all the data, this is a nice study on data on buildings for 40 years. The increase of cooling demand in the buildings that have been analyzed was about 23%. And there was a reduction of the load of the heating load of 19%. So the balance was that at the end, we need more energy for heating and cooling, but that because the cooling is quite higher, the cooling need is growing quite faster than the reduction of heating. And this is pushing the market. There is a threshold that you can see here at about 1,200 CDDs. So when you calculate the cooling degrees days, if you have money, at 1,200 you go and buy your unit. And you go to a saturation rate here. This has been calculated in the United States because in the United States the market is not affected by the income. So everybody went to buy a system or install the system in large commercial infrastructures. This is the picture of the CDDs today. So we understand where they would like to have air conditioning, and it's nice to see that the United States it's not so heavy, but it was the biggest market in the world. China is growing, and again the China affected area is more here in the south. But this is the change in the baseline scenario. So we are going to expand the CCDs as an average worldwide of 25.4%. And we are going to be hotter in the hottest place. So what is going to happen? This is what is going to happen. I picked this yesterday from the presentation about the data here. It's clear that we are going to diverge. And in Nicosia, these are the CDDs in near future. Here we are more or less in the, let's say, balance between heating and cooling. So if the income is going to grow, and this is, nobody would say, yeah, we should keep people poor, because this would be a solution. Let's keep people poor. They will not buy the air conditioning, and the market will be affected just by money. But if you see this curve here, this is again a threshold. So when the PPP per household per month is more, let's say, than 5,000 USD, they buy air conditioning. So again, the saturation is a product of CDDs and income. This is the basic model. And about 2.8 billion of people are in areas where they would need an air conditioning unit, but they have not the money to buy it. So this shift, when people will get into the market economy, they will buy this unit. That's quite interesting in this research by the Lawrence Berkeley lab, that the potential of Egypt, even if they have about, let's say, something not far from 1/4 of the population of United States, the potential demand, if there was not a barrier in the income, would be the 60% of United States. That is an unbelievable size of let's say, market for AC. So all this, let's say, panicking information are going into this. This is the best calculation I have found about the growth of the AC in this century. That is going to cross the heating power about in, let's say, close to 2070. And the curve is almost exponential at this stage. And that's true. It's fitting in the real ones. But why? Because it's not linear. The heat island effect is coming also from AC. So the more we install, the more we warm the city, and then the more we install. We are using greenhouse gases to build the units. So we shifted from the CFCs. Okay, so we are saving the ozone layer, but we are using gases that are 4,000 more affecting the warming greenhouse effect, 4,000 than the CO2. So each time we install a unit, we should think about where this gas is going then, if it is leaking, but even at the end of the life. And of course, this is creating heat waves, and people want more AC, and then you have the crash of the grid. And this is going to be stable. For example, in Saudi Arabia, that weight of the air conditioning goes up to 70% of the electricity distributed in the grid. So they are producing electricity to cool. That's all. So this is my point. Why are we producing electricity just to transform it into cold? Exactly as why are we making electricity to then somewhere else make water? Let's make cold. And of course, this is stressing the grid. You have to oversize it and so on. So it's it's a super duck effect, if you want. But we are also making crazy things as building stadiums that are all full air conditioned. So we are going to live in some countries inside a bubble of air conditioning. This is exactly in line with what Kostas said yesterday about the going to be, let's say, not fitting to the human beings in some parts of the world. We could be crazy enough to create a bubble to go on in using these cities, and we are doing that. This is the stadium in Doha for the World Cup, for the football World Cup. That's full air conditioned. So that's the big plans are coming on, and of course, people in this market, they are very happy about that, because you have a year-by-year growth of 12%. So it's the mecca of people that's Japanese. Usually they are going there, and that's why all the data are available from market for Japanese companies. But we could cut because there is an evidence that improving the quality of appliances and choosing the right model in buildings, it's already evident that we can smooth this growth. The consumption in buildings has not been growing as fast as the adoption of, let's say, technologies and the expansion of appliances. So let's try to do something like that. I found very interesting that a team in Birmingham University, they are lucky because the professors are in the parliament, so it's easy to talk with the politicians because they are politicians. So this professor in Birmingham has outlined that they had never a discussion on coal in the Parliament of UK, and they should have because of the growing, let's say, economy of coal. It's quite interesting that this, let's say, hotspot is in UK, and I will go back on this at the end of the speech. We can do quite a lot to improve the efficiency of this field, and we can combine solar technologies, we can combine innovative systems for making cold, and distributed or not distributed systems, but all around the solar cooling concept. Because we are in phase with the demand, so we can play quite a lot, because we will produce when we will have the need. So we can think different, less storage, somehow less transmission, but we have to really think different to work around the cold demand. We are doing this since very long time. This is a very smart way to make cold where you need cold with a heat. It has been invented 5,000 years ago. It's used now. There is a very nice market of this stuff in Africa, in Nigeria, and all around. They call it pot in pot. It's evaporative cooling, and it's keeping the food preserved. So it's a very important social impact, let's say, on people. It's costing nothing. And there are other examples in the literature of, let's say, old ideas that have been revamped. And also nice inventions from the Mushot combination of compression and dish to the Tabor work in 50s, where they were talking about the solar energy as the way to keep in these regions things going out from oil and from nuclear. There's a discussion. This discussion was in 56, and also Bozza in Italy. Then we had the first pilot plants in United States. It's the work of Lev in Colorado, with a number of installations in houses and in universities. And then a very, very slow, steady, but slow growth. So it's from the early years of this century, about 1,000 units or plants have been installed. That's something, but it's nothing, because we are still there in the forecast of the adoption of solar cooling that the IEA has, let's say, scheduled in 2012. Here we are talking mostly about this. So the concentration and the transformation of energy coming from solar concentrated systems. Of course, you have other solutions, the flat plate and the ECT, and you have all the stuff related to PV generation and then use of, let's say, high performance heat pumps. That's quite interesting. I've been comparing the two, and I'm following this game, and I could say that on the efficiency side we are almost at the same level. Of course, PV plus heat pumps at a basic, let's say, installation would cost less, but they will affect in other ways. I mean, we should calculate it better. It's not just about money. These technologies have been improving. They are quite known, so I think there is nothing so important to say here. And with solar collectors, we can use them at the best of their potential performance, let's say, because the concentrating collectors are giving us access to the multiple effect absorption system, so with a quite higher COP, so the efficiency in generating cold from heat. And also we could work quite better if we need storage. So I think that this is, I mean, one of the solutions we have to pursue. Here you can see the comparison. That's a nice study made on a district cooling installation, a potential installation in Saudi Arabia, published 1 year ago, I think, where you can see that at a medium radiation, that's not the Saudi Arabia, so we are downgrading a little bit to understand if we could have a broader field, let's say, of implementation of this solution. You have that the two effect chillers and 3 effect chillers are crossing the efficiency of the single effect at about a DNI of the 60%. And you have a converging cost at about this, let's say, sides of the plan with a DNI of 70%. So if you have a good radiation, you will not have a cost threshold in using a better absorber, and you will have a better performance. You can also imagine to hybridize. This is a quite clever, I think, approach, that you keep some gas in the system for heating and cooling, and you shift part of the energy that is used for the absorption process. You shift it from gas to solar, and of course the result in terms of COP on the primary energy is quite better than the performance you would have using the gas in a turbo gas alternator and then go to a compression unit and then go to cool. Of course, all these numbers should be updated as soon as a new VC unit is going into the market and as soon as a new absorption unit is going to the market. But the result in projects like this are quite interesting. This is in China. They have been using a gas fired absorber with this power, and they added some solar, and the solar profile is quite in line with the demand. So the result is that just adding, let's say, one-fourth of power on the gas cooling unit, they will save about 2/3 of the gas that was used. So I think this is quite good. It's quite simple, let's say. This is the double effect unit, so you are firing the 2 effects with the 2 different sources. Let's go bigger, because the bigger we go, the better it is. In Gulf countries, the district heating is getting in place, and the largest installations are in that area. This is an installation going on in Doha. There are 2 big ones, owned by I think the name of the company is Qatar Cooling or something like this. And we are talking about a refrigeration capacity of 690 megawatts. So we are at the scale of power plant. So my question is why we are not going to feed it with solar. It's there. Instead of making electricity, we could feed big absorbers or whatever you think it's a better technology. But the size is a size that is competing or is in line with big electric plants. This is again about the study I already presented in Saudi Arabia. What is interesting here is that concentration, if you compare it with flat systems like ETC, is working quite well also in terms of cost. So I would go for a strategy on concentration for these plants of this size. We can also introduce polygeneration as the approach. This was the approach of the STS-MED project. I think that Alaric Montagnino will tell us something about that. So we could produce at the same time or switching from electricity to coal whenever we need it. And we can also start working quite hard on the on storage, because sometimes, for example, in Doha, I would not talk about heat storage, neither about electricity storage. I would go for cold storage, cheap, medium. Cycles are never ending because there's not a big limit in that. And the temperature that you have to keep is quite closer to the ambient temperature than with the molten salts. So I love molten salts, but in this case, why have 500 degrees instead of 50? It's quite easier. And if you need this to chill a place, you don't need 550, you need 0 degrees. So the gap is quite easier to keep with water. There was a pilot initiative in Jordan. I don't know if Professor Suil will tell something, but as we've been working together in STS Med, I think it's interesting to just to spot on this. That was showing that with a very large adoption of the solar cooling in the country, that is quite suitable as a solution for the country, the results in terms of emission would have been very, very interesting and impacting the overall picture. We have a lot of problems, of course. This is the result of a questionnaire that have been submitted by the SHC, so the Solar and Heating Initiative, under I think the task 48. To a number of companies and developers and people that were, let's say, stakeholder of the process. And this is the cloud, the cloud of the answer. That's most give us an idea of the most important things we have to solve. Parasitic, power that we are losing, poor design, control problems, complexity, and so on. But this is the conclusion. As in UK, they are talking about the smart cold economy, thinking about reusing the waste cold from regasifying the LGN. So that's they are importing liquefied gas. Then they have a lot of waste cold, and they are thinking about a system to keep it and use it. I think we should start promoting a specific strategy for this part of the world based on solar to manage, to generate, manage, store, distribute, and use cold. And so I hope that we are going to see a new season of a solar cold case in this area, in this part of the world. Thank you.
Another speaker who has respect with the time limit. So I see already hands appearing. I don't know. Chuck, first question.
A couple of quick comments that I think reinforce your message, and then a question. First comment is the Department of Energy decades ago had a national solar heating and cooling program. They had a lot of flat plate collectors running, absorption chillers. They wound up using lots of natural gas. So the conclusion was you really needed a higher temperature collector in order to run absorption chillers, and I think that aligns with what you said. Also, to reinforce the point about the global warming potential of refrigerants, I don't know how many of you are familiar with Project Drawdown. I recommend going to the web and looking at it. It's a good book. It's 100 different measures to address global warming, and the #1 measure is to come up with a new refrigerant, basically, to get away from these high GWPs. My question is, you mentioned the value of cold storage. So my question is, how do you think chill water storage, like you showed in the slide, compares to ice storage?
Yeah, of course, it's a matter of design. And so it's a matter of where you want to install the system, which kind of, let's say, cold you want to supply. You know that going to low temperatures with absorption process is quite more challenging, and the couple of pairs you need is different. So there is, let's say, less technology in the market for going to low temperatures, let's say below 0. Mostly it's water ammonia. And so it will be cheaper and easier now, I mean, with the technologies we have now to stay above 0. But I think that in future it will be quite better because the, let's say, density of energy is higher. So I would go for that. But I think that if we want to move now, we could do something now above 0.
I had a question on the distributed use of AC, all of the pictures that you've shown. Have you investigated the good correlation between the sun production shape and the need for AC, which almost normally match fully? So yeah. Is a solution of distributed generation with PV connected to an AC solution a better choice for certain cases than a centralized with distributed heat and cooling?
Yeah, okay, you have a shift, and so you need some storage. That's why I think that working on storage is important. You could have even local storages in the settlements that should work, because you have small sites and you have temperature that is not far from the ambient temperature. So I think they will be effective. I believe that we should start making some, let's say, overall studies on this kind of frameworks that are not so enough, let's say, exploited. In literature, there is a lot of references on the technologies, but on the implementation, for example, at the district level, there is not so much. And I think we should push, because the district mentality is from the heating, from the north. This is my point.
So can we put a number? So how much generation is used right away by the AC units in our area, and how much would need storage? Are we talking about 80, 90, less, more? Do we have an idea?
You mean the total energy that is, for example, I think that the maximum now is in Saudi Arabia, and you have the 70% of electricity that is going into air conditioning. So you could work on cooling instead of working on electricity, because you will cut, and it will be worse. For the numbers that we have seen, it will be even more in future. So it will be interesting to use the data on saturation to understand, to forecast the need of air conditioning, and then trying to understand which kind of medium we should use for storage, if this is the question.
There's one more thing. No, we still have 1 more minute for a question.
Couple of points. I was surprised by your map.
Yeah.
Having lived in the United States for 25 years, mostly in the north.
Yeah.
Every place I was there was fully air conditioned.
Yeah.
Because of humidity.
Yeah.
Not because of high temperature. It's a combination. The discomfort factor is not temperature alone is not a good criterion. You have to take into account humidity. Climate change, I'll ask the climatologists here, but I understand not only will get higher temperatures, in any thermodynamic system, you'll get more humidity.
Comfort, yeah.
So the pressure will be not only on the south, will creep into the north. This is anecdotal, of course, but I don't know if this is taken into account. And your map was surprisingly red only in the, for example, the United States.
Was on the degree days. So,
degree, but discomfort factor is the thing that has to be taken, I believe, into account, not temperature. The second point, which was raised by the previous question, is that the pressure on the system using PV as driving the air conditioning will result, this is again anecdotal from Cyprus, into enhancing the DAC curve, because people actually have more efficient air conditioning at work like here, we are using actually very efficient air conditioning as we speak, and geothermal and the Fresnel. But I go home, I have the usual picture that you have shown. And this load on the electric system will come after the sun sets between sunset and midnight. But PV, as we know, doesn't work well after the sun sets. So the dark current will further be
even worse. Yeah.
increased